Ever wondered why it's so hard to reach the dwarf planets? Well, the answer lies in the vastness of space itself. It's a realm so expansive it dwarfs our human comprehension. To put things into perspective, let's consider our solar system. It's not just about Earth, Mars, and Jupiter. Beyond Neptune, in the icy depths of the Kuiper Belt, resides Pluto, a dwarf planet. This immense distance poses a significant challenge. It's not like driving across town or even flying to another continent. We're talking about billions of kilometers of empty space, and this space impacts our ability to communicate with our spacecraft. The farther away a spacecraft is, the longer it takes for signals to travel back and forth. This delay complicates the remote control of these spacecraft, making tasks that seem simple on Earth, like adjusting course, incredibly slow and tricky. So, the sheer distance to dwarf planets poses a significant challenge, but it's not the only one we face. Now imagine having the technology to cross these vast distances. Easy, right? Not quite. Our current technological prowess, impressive as it may be, still has its limits, especially when it comes to space exploration. The challenges are manifold. First, let's consider the spacecraft itself. It needs to be robust enough to survive the long journey to the dwarf planets, which could take years, even decades. It must withstand extreme conditions, such as radiation, micrometeorites, and the icy cold of space. Then we have the issue of fuel. A spacecraft needs enough propulsion to escape Earth's gravity, travel to the dwarf planet, and then, ideally, return. The amount of fuel required is staggering. And with more fuel comes more weight, which in turn requires even more fuel. It's a catch-22 situation. Now think about navigation. It's not as simple as pointing the spacecraft in the right direction and hitting the gas. Space is constantly in motion. The planets and stars we use as reference points are moving. The calculations needed to hit a moving target millions of kilometers away are mind-bogglingly complex. And finally, there's communication. The further the spacecraft travels from Earth, the weaker the signal becomes. Maintaining communication over such vast distances is a significant technological challenge. Thus, even if we conquer the distance, our current technology still falls short. Let's say we've solved the distance and technology issues. What's next? Resources. Now, resources can be a broad term, so let's break it down. First off, we have financial resources. The cost of building a spacecraft is astronomical, pun intended, and that's just the beginning. Once you've got your spacecraft, you need fuel for the journey, and not just any fuel, mind you, but high-grade rocket fuel. Then there are the costs of launching the spacecraft into orbit and the ongoing costs of maintaining and operating the mission. But it's not just about money. There's also the human factor. You need a team of highly skilled scientists and engineers, people who've dedicated their lives to studying the cosmos and designing machines capable of exploring it. These are people who've trained for years, often decades, in their respective fields. And let's not forget the time factor. Planning a mission to a dwarf planet isn't something you do over a weekend. It can take years, even decades, of meticulous planning and preparation. Every detail must be perfect, every contingency must be considered, and even then there's no guarantee of success. So we see that reaching dwarf planets isn't just a matter of packing a spaceship and setting off. It requires substantial resource. So why is it so hard to reach the dwarf planets? Let's take a moment to recap. The sheer distance separating us from these celestial bodies is a formidable barrier. These far-flung worlds reside in the outermost regions of our solar system, making them incredibly challenging to reach. Then there's the issue of technology. The propulsion systems we currently have in place are not powerful enough to get a spacecraft to the dwarf planets in a reasonable amount of time. We're talking years, even decades, of travel. And let's not forget about resources. The financial and material costs involved in such a mission are substantial, to say the least. But let's remember, these challenges, while significant, are not insurmountable. We are making strides in technology and resource management, inching ever closer to our goal. The journey to the dwarf planets may be difficult, but the desire to explore and understand our universe drives us forward. And who knows, one day we might just get there.